Hi everyone, today's topic is direct proportion. So previously we talked about scales, and when we are using a scale to come up with a map or a smaller picture, we're basically showing how a smaller picture is related to a larger picture. We're basically blowing it up or we're shrinking it down in size. When that happens, we are keeping our quantities proportional to one another, meaning that they are still the same, but they are just using a different scale. So two quantities are proportional to each other when they're related in a linear manner, and they're basically increasing or decreasing at the same rate. Make sure that gets added into your notebook because that's a very important vocabulary word. All right, now in order to actually measure that scale and see how they are related in that linear manner, we can tell that two quantities, let's call them x and y, are related and they are proportional because they vary in such a way that y divided by x is a constant. So whenever you take your y value and divide it by its corresponding x value, you should get the same constant value. It's the same throughout because they're related in a linear manner. It's the same. And we actually call that k. Okay, so when you divide y divided by x, it should be the same throughout. And when you see that that is the case, then x and y are said to be in direct proportion to each other. And if we were to come up with an equation for those two proportional quantities, the equation would look like this: y equals k times x, where k is that constant that we found when we divided y by x. And since they're related in a linear manner, then you should get a straight line passing through the origin. That's very important when you actually plot those points. Okay, so there are two main requirements to check and see if two quantities are indeed proportional to each other. Whenever you divide the y values by the x values, they should get the same k value. And then when you graph the line, it should create a straight line that passes through the origin. Remember, the origin is your 0, 0 point. So be sure that you put this in your notebook. All right, we're going to take a look at some examples in the book so that you can see exactly what we're talking about. Here's example 7 from your book. It says the following table shows the traveling time, t hours, and the distance covered, y miles, by a car. So they want you to first show that t and y are in direct proportion, then graph that y against t, figure out the equation, and then find the value of y when t equals 1.25 and the value of t when y equals 72. Go ahead and pause the video and try it on your own first. All right, first off, we need to show that t and y are in direct proportion. Remember, we can show that by dividing our y by our x, t in this case, and see if we get the same constant of k. Okay, so let's do that. I have a whole bunch of different t and y values that are corresponding to each other. So I'm going to go ahead and divide them. So first I have, again, y divided by x, or t in this case. The first one, 30 divided by 0.5. The second one would be 60 divided by 1, and so on, okay? So I'm going to use my calculator. 30 divided by 0.5 is 60. Okay, so the k value is 60 here. Next one, 60 divided by 1. Well, 60 divided by 1, we know that's 60. 90 divided by 1.5. 90 divided by 1.5. It is also 60. Remember, we want that. That's to show us that it is proportional. that it is changing by the same amount each time. 120 divided by 2 is also 60. And then our last pair, y, which is 150, divided by my t, which is 2.5. Is that also 60? Yes, it is. So all of these k values are 60s. So that's how we can show that t and y are in direct proportion. So I'm going to write that down. K, our k value, which is our y divided by t, is always equal to 60. That's how we know that they are in direct proportion, changing by the same amount each time, which is 60. Okay, let's move on to B. So B wants us to draw the graph of y against t. So now we need to actually change these into points on the graph. Normally it's x and then y. Now we have t and then y, okay? So it's just t and then y. So my t time goes down here. It's going by half points. So let's do that. 0.5, 1, 1.5, 2, and then this last one is 2.5. Okay, and then the distance is my y on my y-axis. That's in miles. Time was in hours, so let me be specific there. My distance is going by 30s, so let's do that. 30, 60, 90. It has to go by the same amount each time, 120 and 150. We don't want to do plus 30, then plus 50, right? It's got to be even, our scale. Now let's go ahead and connect those points. 0.5 connected with 30. This is half, or 0.5 and 30. 1 and 60. Then we have 1.5 and 90. 2 and 120. 2.5 and 150. Then we're going to connect them together. Remember, if it is a proportional or directly proportional graph, it should make a straight line, and it does. Okay, so that's what your graph of y against t should look like. It's a straight line. Oh, and the other requirement was that it had to go through the origin, right? And it does. It goes through 0, 0. So we know for sure that the t and the y are directly proportional to each other because we calculated their k and we got 60 for each corresponding pair. They make a straight line when plotted and they go through the origin. So it satisfies all those requirements. Now C wants us to find the equation connecting t and y. Okay, so the t and the y. Oh yeah, remember the equation is y equals kx. We already figured out the k, and that was the 60, right? So y equals 60 times x. That's our equation. Y equals kx, and our k was 60. Oh, but we don't have an x here. We have a t. So let's just change that to y equals 60t. Okay, now that's our final answer. Now we need to figure out, find the value of y when t equals 1.25. Okay, we have an equation, so no big deal. If y equals 1.25, instead of y, I'm going to put in 1.25 equals 60 times t. I need to solve this equation to figure out the t when y equals 1.25. I'm going to divide both sides by 60 so that that cancels. So then t would equal to whatever 1.25 divided by 60 would be. 1.25 divided by 60. Oh yeah, it is this answer. Okay, 0.02. Okay, so when you've traveled 1.25 hours, you will have covered t is 1.25. Yeah, when you traveled, oh, find the value of y when t equals 1.25. Whoops, did that wrong. I needed to y equals 60t. I need to put t equals 1.25. Okay. Good thing I checked to make sure my answer made sense. So instead of t, I'm putting in 1.25, not instead of y, putting in 1.25. Okay. 60 times 1.25, that's 75. Okay. So that means when you've traveled 1.25 miles, or sorry, when you've traveled 1.25 hours, t is hours, you will then have traveled 75 miles. Okay, that makes more sense. Okay, now E. Find the value of t when y equals 72. Okay, now instead of y, we're putting in 72. 72 equals 60t. Now we divide both sides by 60. So now t equals whatever 72 is divided by 60. 72 divided by 60 is 1.2. Okay, 1.2 hours. So they want to know when you've traveled 72 miles, how long would that have taken you? 1.2 hours. Okay, those answers make sense. So in summary, when two quantities, x and y, are in direct proportion to each other, if I were to give you any two pairs of values, any coordinate points, then we know, right, when I am to divide, the y's together should equal to my x's divided together because they're proportional, follows the same rules of proportionality. So now example 8, the height h centimeters of a pile of books is directly proportional, so they're telling us it's directly proportional to the number of books n in the pile. The height of a pile of 10 books is 15 centimeters. What is the height of a pile of 24 books? So you're going to utilize what we just talked about up here to solve that. Go ahead and pause your video and try it on your own first. Okay. So you know what? I'm going to actually make a table because I want to organize what's going on here because I'm talking about height of a pile of books and I'm talking about the number of those books. So number of books and height. Okay, so the height of a pile of books is 15 centimeters. 10 books, 15 centimeters. They want to know the height of the pile of 24 books. Oh, they want the other thing, 24. And then the height is what they want. Okay, so that's what they want. According to what the book tells you, you can basically take the two y's and divide them to figure out what your missing value is. Okay, so you can do this one of two ways. You can actually follow this formula. So I'm going to take my 10 divided by 24, basically set up a proportion here. Set it up like this, okay? And this is why making that table is really convenient. So then it basically is just copying it over, putting some fraction bars and setting an equal sign. What you can do is cross multiply. So it would be 10 times x, 10 times we don't know, equals 24 times 15. Okay, so 24 times 15 is equal to 360. So then 10 times x equals 360, divide by 10 both sides. So x would equal to 36. Okay, so then the missing number in here is 36. Okay, so that's one way of solving this problem using that formula that the book gave you. Okay, the other method is basically using what knowledge you have from before when we were working with our percents and also our ratios, basically the knowledge that you have already when you see a table. Now, when you see a table, you can figure out their relationship by dividing, right? 24 divided by 10 would give you 2.4. So really, this 10 has to multiply by 2.4 to get to 24. This should look familiar to you when we were dealing with our tables. Remember, we drew our arrow to show that it's going in this direction, right? 10 has to multiply by 2.4 to get to 24. You know this because you divided those together. Now, if that's their relationship, then on the other side for height should also be your relationship, times 2.4. 15 times 2.4 will also get you to 36. That's another way you can get that answer, okay? And then there's even a third way for those of you who like to draw out a double number line on how to solve this. You can make a double number line, your n's to h's. Okay, so then I need to write down the information I know for n and h. For 10 books, the height is 15 centimeters. So I'll need to work backwards and break this down just like my percent problems to figure out what the height is for one book. For one book, I need to take that 10 and divide it by 10. 10 divided by 10 to get to 1. 15 will need to divide by 10 as well to match that. 15 divided by 10 is 1.5. So for one book, the height is 1.5 centimeters. I'm not done though, because the problem wants to know what's the height of a pile of 24 books. So 1 needs to multiply by 24 to get to 24. So then, of course, 1.5 also needs to multiply by 24 to get to the answer. 1.5 multiplied by 24 gets you to our answer of 36, okay? So just like the problems we worked on previously, many different methods to solve this because it is directly proportional. Okay, here's example 9 from your book. The weight of a solid metal sphere and the cube of its radius are in direct proportion. When the radius of the sphere is 2 inches, its weight is 192 ounces. Find the weight in ounces of a sphere of radius of 1.5 inches. Okay, pause the video and try it on your own first. Okay, so we are talking about radius and we're talking about weight. So let me make a table. When the radius of the sphere is 2 inches, the weight is 192 ounces. Find the weight, so we don't know this, in ounces of a sphere of radius 1.5 inches. Okay, both in inches, both in ounces. Okay. So remember, the first method is you can use your proportions to set this up. 2 over 1.5 equals 192 over x. And then we're going to cross multiply. So 2 times x going across equals 192 times 1.5. 192 times 1.5 is equal to 288. So 2 times x equals 288. Divide both sides by 2. So then x would equal to 288 divided by 2, which is 144. And that's how you would use the proportional ratio method to find the answer, okay, 144. But remember, that's only one of the methods. You could have used just the table to figure it out. So let's do that. Using the table, you can divide 2 and 1.5. 2 divided by 1.5. Ooh, I don't like that. Let's do 1.5 divided by 2. Yeah, 1.5 divided by 2 was 0.75. Okay, so let's check. Is that 2 times 0.75? That'll get us to the 1.5? Yes. So let's multiply by 0.75, going in this direction. Great, that's the direction we want. So we'll also multiply the top one by 0.75 to get to our answer. 192 divided by 0.75 to get 200 and, oh, sorry, we multiply, right? 192 multiply by 0.75. Okay, 144. Yeah, very important that you multiply instead of divide if that's what you have to do. All right, so that's the second method. And then remember, the third method is your double number line, where you are going to build yourself down, and then build yourself back up again. Okay, so we have radius and weight. We have a radius of, utilize my space here, 2, corresponding to 192 ounces in my weight. So if I were to go back down to 1, I would take this 2 and divide it by 2 to get to 1. So then 192 also has to divide by 2 to get to that corresponding weight. 192 divided by 2 is 96. Okay, so a radius of 1 is going to weigh 96 ounces. I need to figure out the weight for 1.5 radius. Okay, so if I want to do 1.5, I would have to take 1 and multiply by what to get to 1.5? Well, it also would just be halfway there, right? So I could figure out what half of this is. Half of 96 is 48. So if I just do 96 plus my 48, I should get my answer. Because this is 96 is for 1, radius of 1, and then 48 is a radius of 0.5. So add those together, I would get the radius of 1.5. Okay, so 96 plus 48, that's 144. So any method that you choose should get you to the correct answer.